So in exponents, I find that if I write out what it means, x squared means x times x, doesn't it? I mean, that's what that means. And x to the third means x times x times x. And there's a times right there. Duh. Look at that. Now, if you wrote out what it really means, is there any way you would think that that was x to the sixth? I mean, look at it. There's 5 x's. To me, it becomes really obvious. Oh, I guess it's these 2 and these 3. That makes x to the 5th. So you should not have to guess. 50-50 chance. It's either multiply the numbers or add the numbers. You can think about what it really means. I'll give you another one that's like that. X to the third over x to the second. And you're like, oh, crap. Well, I probably not add because we just did that one a minute ago. But if you write out what it really means, this means x times x times x over x times x. And then I think you know that each of these will cancel each other. They canceled out. The answer is just x. So you can look back and go, oh, I guess I was supposed to subtract the powers. See what I mean? 3 minus the 2 makes x to the 1. See what I mean? So you shouldn't have to just guess. Yes, it's true that the powers just subtract. But x to the third is xxx. X squared is xx. If you just write it out, this is called exploded view. There's actually an awesome website that has exploded views of common things. And it's really cool. You can take your iPhone and they do an exploded view of it. And they basically just separate it into all of its little parts. So you can see all the pieces that are in an iPhone that are all put together. You know what I mean? The exploded view. So what I'm saying is, when you're stuck on a problem that's like, okay, he says that we can just like write out what it really means. I think you forgot your headphone in there. You're in the front row, so you know I can see it, but you probably just forgot. All right. So the what does it really mean thing? Exploded out. X to the third, it means x times x times x. And then I'm not sure really what squared means up there. But do you agree that x to the third is xxx? Right? Do you remember that? Okay, so then, now I just have to go, okay, what does squared mean? It means times yourself. That's what that means. And now when you look at this, the original problem's right there. And some of you are going to play the game of, well, I don't know, I think you multiply, but maybe you add. What you should do is this. And then you're going to be guaranteed to pick the right thing because nobody would pick x to the 5th. If you're looking at this, nobody would pick x to the 5th. You'd say, oh, it's probably x to the 6th. Okay, so yeah, that's the kind where you multiply the powers. At the end, you get good at it and you don't have to make the exploded view anymore. But if you're ever stuck, which some of you will be on the test, you'll be like, oh, I can't remember, is this the kind you add or the kind you multiply? Write out what it really means. All right. Now there's another kind of exponent that's a little harder to do that with, and that's negative exponents. So what does that really mean? Okay. Would you agree that there's 2 parts to it? It's just x to the third, and it's got this negative. Well, that means it's something to do with x times x times x, because that's what x to the third means. But it can't just be this. The negative of it means 1 over that. That's what that means. X to the negative third. The negative in the power means you put 1 over it. That's like flipping it over. If you had 2, it would turn into 1/2. You know, like you flip it over, put 1 over it. All right. So, another way to think of this is that this negative people are unhappy. It's pretty much true. You probably know some negative people. I remember I had a friend who was just like, that sucks. Everything just, you tell them about a movie, that movie sucks. It was just negative all the time. Well, they aren't happy where they are. This is a way of thinking of it. So if you have this x to the negative third, you can always put over 1. That's true. Of anything from now on, if you want to put divided by 1, you can. Always. So then, it's not happy where it is. I can just move it down here, and it'll be happy. And look, I need something to hold the place on the top, so I put a 1 up there, and look at that. That's what this is. It's 1 over x to the third. So the negative exponents, they're just not happy where they are. See, that way works pretty good when you get to problems like this. X to the negative third over x to the second. Because otherwise you're going to get confused on what to do with the powers. But if you just go, well, this guy's not happy where he is. Let's move him to the other level. Maybe he'll be happy there. So when you move it there, it has to be x to the positive third. And remember, you need something to hold the place, otherwise your whole fraction would dissolve. So there's a 1 up there. And now I have my final answer. 1 over x to the, and do I multiply or add? Well, take a second and go, that's xx, that's xxx. Oh, I guess it's x to the 5th. I guess you add on that kind. See what I mean? So if you're ever struggling, pro tip, you can just try to guess, and you probably will get the hang of it after a while and start guessing right. But if you have to, explode the view, and that'll become obvious. I guess it's 5 of them. There's your answer. Now, one thing, little weird math rules, like, in English, you have to end the sentence with a period. You can't just leave it there. There has to be a punctuation at the end. Just a rule. Could you read it if it didn't have a period? Sure. But they have this dumb rule. It has to always have a decimal or something at the end. Could be exclamation mark. Some punctuation at the end of a sentence. In math, we have a rule. You can't leave your answer with a negative power. Negative powers are just not allowed in the answer. I don't totally agree with this rule. I think it should have to say that in the directions. But it's just kind of like you always have to end any sentence with punctuation. It's just a rule. You guys all know it. You deal with it. Well, you can't leave answers that have a negative. Otherwise, you could have said that this was x to the negative 5th because they are the same thing. But math rule, can't leave negative exponents. Therefore, that's the better answer. This one's the one you want to give because you can't leave negative exponents for an answer. All right, let's see if you've caught up. It's only been an 8-minute long lesson, but let's see if you've got the idea. Here is a typical set of 3 questions, and I, yesterday, intended to, but I didn't, get you guys to, get paired with a person across from you. It's going to be rows 1 and 2 we're going to compare, rows 3 and 4, and then I'll pair you with somebody. And I want you to label this question A, question B, and question C. And I want you to tell what you think these 3 answers are. They're not going to be super hard at first. And I'm going to have you compare it with that person next to you and see if you get the same thing. X to the third over x is one of them. X to the third, and the last one's going to be x to the 4th times x to the 3rd. If you get stuck, then do the exploded view. Do you get that really means xxx? All right, figure out what the answer to A, B, and C is. And then it's actually, since you're the first time you're going to be talking with this person, it's more important you just why don't you just compare answers just for A. Just see if you get the same thing for A, because that's quicker and easier. And I want you to introduce yourself. Now, when you introduce yourself, I don't need you to say it in any particular way, but I want you to give them your name, and I want you to tell them one thing. I'm not one of those teachers that wants to make you memorize everybody's name in the whole class. It just seems unnecessary, but you should know one person. And if you happen to have a friend that sits in front of you or behind you, great, lucky for you. But if you have one person that you didn't know before who's right across from you, you should know their name. So I'm going to ask you to write down their name on your, just the temporary piece of paper you have in front of you, the virtual paper. Just write their first name down. Because you're going to be talking to them every day, briefly, for a long time. All right, so just want to give them one thing about you and your name. I also want that one thing, so just think about what that thing is going to be. Like for me, at your age, I would have said basketball. I love basketball. I would sit in class and I would figure out, I was really good at one-on-one. And yeah, I played on the high school team too, but I was particularly good at one-on-one. And I would think up good ways to okay, so I'm going to move this way, and that'll get him going that way. And then I can turn and I can do a fadeaway, and there's no way he's going to be able to block it. If I can get him leaning that way, and then I can do a fadeaway, it's going to just be the perfect. And I think about what friends were good at this and that, and I'd oh, this is the perfect play against this guy, because he always, he's strong to his right, but he's not good to his left. Anyway, so I just do little plays that I was good at for one-on-one. So I would have probably said basketball. If I'd have known my future, I would have said that I would be really into these new technologies that didn't exist back then. I'm fascinated with ChatGPT. There's going to be robots walking around soon, very soon, and I think that's really cool. That we'll probably have robot custodians within 5 years. Not kidding. I'm not saying they'll all be robots. There's going to be robots walking around this hallway in 5 years. I will guarantee it, because robots can work for about $2 an hour. And what would pay a normal custodian is $20 an hour. Don't you think the district would like to save that $18 an hour? Of course they would. And again, they won't start with all robots. They'll get a robot though, really quick. They already have a robot. It's the one that waxes the floors. It costs them $60,000. And they do that because it's really cheap to operate, and it just makes the floors get waxed faster. These robots will be way cheaper. They'll look like a humanoid, and they'll be way, way, way cheaper than $60,000. So they'll be, anyway, so I'm excited about the future. If I were to say what I would have said if I had known the future, I'd have told myself to buy Bitcoin too, that's for sure. When I was your age, it didn't exist, but when it first came out, you could have got Bitcoins for 10 cents. Now Bitcoins are $50,000 each. Imagine, how many would you like for 10 cents if they were going to turn into $50,000 someday? Fascinating to me. But you can't know the future. We can predict the future once we kind of start seeing it, but never saw Bitcoin being big. All right, these two rows, it's the person across from you. Now, again, I get, you two guys are friends, obviously, and that's totally cool, but you can't leave out this girl over here because you just happen to be friends. You know what I'm saying? Yeah. So, for today, you two guys are going to be brothers, and for today, there's nobody over here, so you two guys are brothers. And you two, and you two, and you two. And in these rows, it's super simple. It's just the person straight across. That leaves out you, but I got a plan for that. Person straight across, it's going to be you two, and you two, and you two. And you're going to compare, you're going to have to do double duty. Oh, that's right. You guys can make a little box of 4 right there that can compare to you two. I think that gives everybody a partner. Introduce yourself to that person, please. That's good. Write down their first name on your paper. Just write it down. Write down their first name. Totally fair to ask them how to spell it. I know a woman named Kristen, and it is not spelled how you think. I guarantee it.
So why is it?
Okay. Now, if you haven't already, talk to him about that first answer and the second answer. What do you think the first and second answers are?
I saw you over there. It's simple. The third one, of course, time just means once. And of course, since this is done here, you want to get us here.
You guys compare? Okay, cool. All right. Here's what I mean by exploded view. This is the top and this is the bottom, and then these two cancel, so that one's just x squared. Raise your hand if you had the first one right. Awesome. Then this one's x to the, well, it's either 6 or 9. And if I'm like deciding between those two, I'm going to make it like this, and then I'm going to go, okay, that's what x to the third means. But then what does this to the third mean? Oh, yeah, it means do it 3 times. Now you should be able to go, oh, I guess it's x to the 9th, not x to the 6th. Really common mistake, but x to the 9th was the right answer. And then on the last one, I hope you don't have to actually write out all the x's to go, okay, there's 4 of them here, there's 3 of them here. I guess if I did write them out, there'd be 7 of them. Yeah, x to the 7th. Does that make sense? All right, now let's move up a level. What if you got negative exponents in it? Would everybody get what you think that answer is? Remember, they're not happy where they are. That's the way I do it. You could make this have a power of 1 and then do something with the powers, but I'm telling you, I think it's easier to just move those unhappy x's. And remember, your answer can't have a negative power. Just like, it's just a rule of math. You're not allowed to leave an answer with a negative power. Kind of like you're supposed to simplify fractions. All right, did you realize that that would move down there, and therefore your answer is 1 over x to the, and then you got an x to the 1 and x to the 3rd, but then you can put them together. So 1 over x to the 4th. Raise your hand if you had that one right. Okay, cool. Any questions about that? Okay. So this is the part in class where we stop doing that stuff for a minute and we take a minute and talk over the most missed basic 20 things. And I looked and saw which things gave people the most trouble, and fractions was definitely up there. And so I want to take a second to talk about what do you do when you multiply them, what do you do when you divide them, and what do you do when you add them. Now, there's a real fear from some kids in fractions, like, I'm terrible at fractions. Well, do you realize when you learned them that you were like 8? Do you get that now you is like infinitely smarter than 8-year-old you? You are so much smarter than 8-year-old you. So if I teach you fraction stuff now, you might all of a sudden get it, where you might have been doing them for 2 weeks in Mrs. Johnson's class and you didn't understand them back then because you weren't able to yet. You're way smarter now, so see if you can get them now. It's really not that bad. On multiplying fractions, you just simply multiply the top and you multiply the bottom. It is that easy. Now, some people think cross multiply. They told me cross multiply. That was a thing, but it was a thing when you were setting 2 over 3 equal to like x over 5. That's when you cross multiply. That's not what we're doing. We are just multiplying 2 fractions. You just multiply across the top and the bottom. That's it. And then sometimes you have to reduce the answer. How come that is so much harder? Because dividing fractions just sucks. So honestly, I don't know a single math teacher that actually divides fractions. Not even one. We always change it to multiply. But can you just change it to multiply by 4/5? No, that totally would be changing the problem. You can't change it from a divide to a multiply unless you flip this one. And so this one becomes 5 over 4. See, you're just changing the problem from a divide 4/5. And you don't want to do that because it's too hard. Even math teachers don't do it. And you change it to a times 5/4. So then this becomes 2 times 5 is 10, 4 times 3 is 12, 10 twelfths, and 10 twelfths does have to be reduced then. So what do you do to reduce? I know some of you are like, oh, Mr. Server, we all know how to reduce. Actually, you don't. Not all. Some people do. Most people do. But to reduce 10 twelfths, I think the best way is to go 5 times 2 and 6 times 2, because I think you can all do that. You can change them to times. And then look, boing, 5 6. It's so much easier than trying to think of a common factor and divide it out in your head on the top and the bottom. Change it to 2 multiply problems. That's called factoring. Do you remember me saying that factoring was the number one thing you were going to have to do this year? It's the big kahuna. Out of everything math-wise that you learn, you'll be factoring more than anything else. It's going to come up in like a whole test on factoring, and then there's factoring in the next several tests that's just built into the tests. You've got to be good at factoring. So you got to be able to think about 10 is what times what? 5 times 2. 12 is what times what? 6 times 2. You also will have to factor things like this. But we don't have to worry about that for today, but x plus 5 and x minus 5. That's called factoring. You learned it in algebra a long time ago. But if there's one skill, it's all these different kinds of factoring. For this year, Algebra 2, factoring. If I can only bless you with one thing you could do really well, it would be factoring. For basketball, if I could bless you with just one thing you could do really well, it probably would be shooting. Because if you can just run down to a spot, get open, and somebody throws you the ball, you can shoot. If you can shoot and make it every time, holy crap, you'd be like, most wanted basketball player in history if you just made it every time. But in math, if I could give you just one thing you could do for this year, it'd be factoring. So if you suck at it right now, get better. All right. So this is the part where I need to go to, I just talked about add, subtract, multiply, and divide fractions. Oh, wait, I didn't do add yet. So what if I had 2/3 plus 4/5? Would everybody please write this one down? And some of you just know this like the back of your hand, and I apologize. I need to have you look at it anyways. Very soon, you're going to be allowed to have phones out, but I want to be really clear. It just happened, but I want to be super clear. If I catch somebody on their phone like this, it'll be super obvious that, they're not supposed to do that, right? But I don't even want it on your desk. If it's on your desk, that's what we're being told. That counts as we have to send an email home. Okay, so don't even have it on your desk. Even if you're not using it, it can't be on your desk. Otherwise, I don't like it. I wish I didn't have to do that, but I do. Okay, so the common denominator thing, I think people made it way more complicated in elementary school than it has to be. Just multiply them. The common denominator is 15. You just multiply them. There is a more complicated way, but we don't need you to do that. If you can just multiply them together and say, I want these both to be 15ths, that's all you do. If I can put them both in 15ths, it'll be super easy to add them. So how do I get them to be in 15ths? It's not too hard. Take the 3, and what do you have to do to the 3? Times it by 5. And you do that on the top and the bottom. Same thing here. How do I get the 5 to be a 15? Oh, times it by 3. And if you do it there, you got to do it there. It's kind of like keeping it fair. If you got a brother or a sister and your mom gave you $100 and didn't give it to them, like, what? Your brother or sister would be pissed. You can't just multiply the bottom by 3. If you multiply the top and the bottom by 3, it keeps it fair. Okay. So now 5 times 2 is 10. 4 times 3 is 12. Add them together. 22 15ths. And I hate the word improper because it makes it sound like you can't leave it that way. In Algebra 2, we totally leave it that way. It's fine. You don't need to divide that on a calculator and get some decimal. You can just leave it like that. That is a good answer. There's a reason it would take too long to explain it, but I guess I can. If I put a variable on it, then it's fine. You can have a problem like this in any math test. You can just slap the variable right on this number. But if you had a mixed number like 1 and, 7/15, that is an illegal thing to write. So we don't even like you to do that. Don't do that. Leave it like this. All right. Now, here's your final test on fractions. 3 questions, because add and subtract are pretty much the same thing. I wanted to have you multiply these two. 4/3 times 5/4. You don't even have to write the problem down. You can just write the answer out. B, 4/3 divided by 5/4, which you will just change back to a multiply. And C, 4/3 plus 5/4. Can you add them? Can you subtract them? I add them, subtract them. Can you multiply them? Can you divide them? Today's homework is going to be a plain old-fashioned paper worksheet. I like to get out of the iPad sometimes. I think these worksheets are sitting on my desk. Dang it. I'll go and, after I give you the answers for these three, you know what? I think it's actually smarter. It's going to take you a minute to finish this anyways. So I think I should run and get them. I'm going to pause for a second. So on number 1, you just have to multiply across the top. 5 times 4 is 20. 4 times 3 is 12. Can I leave it that way? No. So I got to simplify my favorite way. 2 times 10, 2 times 12. Would there have been a smarter thing to do? Yeah, but this would work. And then I could go 2 times 5, 2 times 6. 5, 6 is your final answer.
I have a question.
Yes.
Where did the 2 come from? 12.
Where did the 2 come from on the 12?
Yeah.
Oh, God, Jiminy Cricket. 2 times 6. The 2 is fine, but that shouldn't have been a 12. 2 times 6 makes 12. Ugh. 10/6, and then, thank you, you caught me. Going too fast. 2 times 3 here. So, there we go. 5/3. Do you guys agree on 5/3? Did anybody get 5/3? All right, a bunch of people did. Okay, good. All right, on to letter B. I don't like to divide. No math teachers divide. We change it to times. Times 4/5. You can't just keep it the same. You gotta do something to it. There. And now it's 16 over 15, and that's good enough. You don't get any bonus points for saying 1 and 1/15, because this is good. All right. Then there's this one. 12 is the denominator you want. They're both going to be 12s. How do you get it there? You times it by 4. Keep it fair. If your parents gave you $50, they better give your brother $50.
No.
And then times 3 and 3. And now I got 15 12s and 16. And I add them. And I get 31 12s. Good enough. Don't have to mess with it. It's improper, yes, but we like improper at this level. Okay. How many of you feel like you have got those down? Raise your hand if you're feeling good about those. All right. I'm noting some people that aren't raising their hand. I know some of you are like, I don't want to raise my hand, it makes me look dorky or whatever. But if you don't, then it makes me go, oh, I better talk to them during work time because they don't understand fractions. All right. So here is your worksheet, and I think you're completely ready for it. But beware, most worksheets you, of course, would have to go onto the back side and do both sides. For today, it's a 2-day worksheet. You're going to do the front side today, and then the back side on Monday. Just do the front side, please. You are totally allowed to use
You actually.
Cell phones during this time because it is work time.
You said you use your.
Thanks for keeping away until now.
Yeah, I still have one. They play games. I'm so happy. Thank you. Oh no. Yes.
If you get stuck, write out what it really means. Like x to the third, make it xxx. And then you'll quickly realize what to do. Cell phones are fine during this time. You don't have to be like paranoid. You walk past cell phones. Yes. I do. Come on up. I'll show you how I do this. If you ever want to borrow a charger, that's the first person to ask in first hour. I have this block. And then you just take it to your desk and plug it in.
Thank you.
You're welcome.
Do we only do one page?
Yes, just the front side. It should feel a little easy, but today would be the type of day where if there's even one of them that you don't understand, you should walk up and ask me. Yes, you can always just take the pencils, no problem. I do hope that you will return it because I don't have like an infinite pencil maker machine. Okay, one last thought. I didn't talk about this much, but do you remember what anything to the zero is? One. If you ever see something to the zero, it's just one. Anything to the zero power is one. I can show you why. It goes like this. 2 to the third, that means 2 times 2 times 2, which is 8. 2 to the second, that's 2 times 2, which is 4. 2 to the first, everybody understands that's just 2. If you follow the pattern, half of this, half of this, half of this is 1, see? Anything to the zero power, if you just follow the pattern, it'll be 1. Yes, sir?
Do you happen to know what Mr. Fry is?
Can you repeat about the question about Mr. Fry?
Where is he?
Like right this second?
I guess, like, what classroom is he in?
Mr. Fry, okay, that's a fair question. I don't think I need to record the video though, so I think that's it for the video for today. It's a worksheet, you just do the front side of the worksheet, problems 1 through 15.